If we have an exponential function in the form of f of x equals b to the x where b is greater than 1, then we could say these facts about the function. The domain is a set of all real numbers from negative infinity to positive infinity, and the range is a set of all positive real numbers from 0 to infinity. There are no x-intercepts, and there is a y-intercept at 0, 1. There is also a horizontal asymptote at y equals 0. And if b is greater than 1, it is an increasing function and is 1 to 1. This is called an exponential growth equation, and this is important later. The graph of f contains the points negative 1 and 1 over b, 0, 1, and 1b. The graph of f is smooth and continuous with no corners, sharp turns, or gaps. So a rough sketch of this graph is going to look like this for a growth equation. It's going to start low, and then it's going to go up high very, very quickly. So this is what an exponential growth equation is going to look like, or an exponential function equation that's growing. If we have an exponential function in the form of f of x equals b to the x, and b is between 0 and 1, then these are the facts we could say about this function. Many of them are going to be the exact same. The domain is a set of all real numbers from negative to positive infinity, and the range is a set of all positive real numbers from 0 to infinity. Again, there are no x-intercepts, and there is a y-intercept at 0, 1, and there's still a horizontal asymptote at y equals 0. If b is between 0 and 1, we say this is a decreasing function, and it is still 1 to 1, and this is called an exponential decay equation. The graph of f contains the points again, negative 1 and 1 over b, 0, 1, and 1b, and just like before, f is smooth and continuous with no corners, sharp turns, or gaps. So the basic graph here, that's a decay equation, is actually going to start high, and then it's going to go low, like so. So it's essentially just going working the opposite direction from the growth equation. Now there are transformations, and these transformations for exponentials are similar to the others. They can be shifted left, right, up, down. They can be stretched vertically or horizontally. It can even be reflected upon the x and y axis. Now all these are important, but you really need to pay attention to the shifted up and down as it moves the horizontal asymptote up and down. And knowing if the graph is reflected is also good so we know the shape and the orientation of the graph. These two things are the most important, at least in my opinion, when trying to graph an exponential function. But if you want to know all of them, these are all the translations of an exponential equation or an exponential function. There is the vertical shift, there is the horizontal shift, there is the vertical stretch and compress. We still have reflection about the x and y axis. And this is a kind of general equation for all the transformations. So if you like doing transformation of functions, this is what you're going to want to use when graphing an exponential function.